as we look west out the door through the window, where the sun is dropping to the horizon. That tells us that the angle to the top edge of the sun at that time from the bottom edge of the window. This is what's producing the 0.955. So the sun's just in general, everybody knows, everybody who's been in this argument as long, anywhere near as long as I have, everybody talks about the sun's apparent angular size. And that's commonly rounded to about zero point 0.5 or a half of a degree. And that takes us to page 9 in calculating how much of the sun we are still seeing as it fades out. So beginning of page 9. This is the left side of the graphic we were just looking at, just way zoomed in. And the black line is still there. It's still the horizontal reference of the vertical height of the bottom edge of the window brought across to the peak. So the green line is the ridge peak, 16 meters above that, 1,400 meters away to the west of the window. And the red line is what I just described. That 0.995 is the bottom edge of the window on the wall through the door, right to left, all the way up at 0.995, 1,407 meters away to the west ridge there. And we see that this vertical point in terms of altitude is 24.3 meters above that black line, which is the bottom edge of the window. The difference between those two heights is how we produce the 0.34 apparent degree difference between the two when you're looking at it from the door. As a fraction of the commonly accepted angular size of the sun, that should precisely represent only 68% of the sun's size. But many of us here have seen countless video observations of the sun as it approaches the horizon, where we see that the vertical height of the sun is compressed as it does approach the horizon, and significantly so. That you don't need any special tools to see it. You'll notice that every time you take the time to look at it, such that in a case like this, with 0.34 degrees, it would actually comprise more than 70% of the apparent angular size of the sun when it's right at the horizon like this. So I went in between and I just rounded it to 70% for sake of the argument on both sides. Again, this is a situation where we're actually helping the globies a little bit in terms of the figures that we're adopting here. That it's actually more than 70, but we're just going to call it 70. So the net of these figures indicate that the sun is well above the distant physical horizon when arriving at the point at which it fades out due to the opacity value of air. Right here, this is where we're talking about refraction, which is frankly nothing more than distortion, and is indeed serving to compress the vertical angular size of the sun. But the globies, in an attempt at refutation, may assert how the apparent position of the sun is raised at this point. This assertion is only relevant when we're talking about which specific moment at which the sun is alleged to eclipse the Earth's distant horizon. Sun's going down, right? It's just a question of what moment that is. But the assertion about refraction here will only serve to change the apparent time at which the sun supposedly drops out of sight. Nothing about the actual analysis and the points that we're looking at here. So that takes us to the rest of page 9. And that brings us back to the two hypothetical statements, H0 and H1. I hope that all of you have fully come to grips with what I present here, in that the data from both observations, November and February, serve to negate H0 and confirm H1. And if you go to my BitChute video, it's the latest one that's up there. Right on the end of that video, I tacked on some footage from Dave Weiss when he grabbed his drone, went up on top of a nice hill when his buddies were still down at the beach watching the sunset. He sent his drone up, 200 feet or something like that, to film, to record the sun disappearing. And that footage right there confirms everything that I have just shown you. So the bottom line is that it's game over, gang. The Earth appears flat. And that is the end of this presentation. It's a short and sweet kind of thing. I'm just putting in the text chat if anybody feels like showing some monetary appreciation. You can catch me on my Ko-fi account /manofstone for continuity's sake. And that's the point at which I opened it up for questions, guys. Questions, comments. What do you think about that?
Sorry about that. My hands were wrapped up, but yeah, man, like I said, I seen the shadow reveal when he did the blender thing, and I've been kind of, I don't have a west facing window where the buildings block it out where I'm at, so I'm kind of waiting for someone to follow this up. And the way that you know, put the presentation, the Prezi together with the measurements and everything, with even the trig, related to angular size and distance and whatnot, is impressive.
Yeah, thanks, man. And you don't need to have a house in order to replicate this. All you need to do is stand up a board of
True,
any
true.
sizable, cut an opening into it that's got some vertical opening to it. It doesn't even have to be very wide because we're only measuring the one component, and then put another wall east of it, parallel to it, and align them with where the sun is going to come down and hit the horizon, so one casts a shadow on the other, and you can duplicate this. No special anything required. All you got to do is just set it up.
True. Another one of these, things that simple methodology that's out there as we continue to get more and more data points and more people recreating it.
Yeah, the
Uh,
word is replicable.
Replicable facts.
Else out there, what do you guys think about that?
It's one more nail in the coffin of globe theory. One more nail in the coffin.
I
Kind of
thought
waiting for
slide
good
seven.
refutation. My bad. Hey.
No, that's cool. I just have a quick one. I'm gonna go back to rolling out, but I thought slide seven was a showstopper. I thought slide seven was really the nail on the head, and just a really good way to explain the sun fading out rather than setting. I feel like it was so telling, and it's just so good to see it visually, and it's something that people visually can relate to because they've all seen it when it comes to light gradually leaving. So I thought slide seven was great, but the whole presentation was great.
So glad you think so. And you're right. It's that everybody's seen it, but how many people were actually paying attention? How many people were actually at a place, at a vantage point where they could see the effect that I've recorded here? That's what's really important. And being on the beach, that's not the place. Clearly.
What any had there been any takers, any refutation, any attempt to show something different that supports the globe as far as the shadow angles?
I would say I just think he didn't account for the first phase of twilight. If you notice in the diagram, C and D are angularly the same position. That's because I believe the sun is below the horizon at that time, and the light that's casting through is ambient light. Uh, that
Okay,
corresponds with that
copy.
phase of twilight.
Copy. First off, Twilight's got nothing to do with this because all of this takes place before Twilight. This happens with the sun leaving our sight by whichever method, by whichever piece of motion. What we're trying
Yeah,
to
when it,
establish here is, did the sun fall below the horizon and disappear, or did the sun simply move away and fade out due to the strict opacity value of air, and that it simply doesn't have enough radiative energy to break through it anymore to still get to you as it's moving away? This is a geometric analysis. This has nothing to do with twilight.
That's understandable, but is the sun still in the sky between the time difference of the model for C and D?
Model.
You said no?
Which model? I'm asking you. You need to specify your question, Coffee.
For the model with the dates, November and February, they, if you notice, C and D are both at the same angular position. What I'm trying to figure out for both of those models, the time between them, was the sun still in the sky?
Absolutely. You point the deal here is that when you look at the graph, which shows you what happens between C and D, and that they are a minute apart, and we're talking about the sun and its constant rate of descent, that rate falls to zero as it fades away. You see, it does not continue at the same rate of descent as it's fading out.
Yeah,
Quite the
but
contrary. The
if you're
opposite of that happens.
if you're corresponding that to the brightness of light, you're gonna be misled because the first phase of twilight. That's why I'm asking you specifically, was the sun in the sky? Like, did you see it?
You don't have to see it, the wall sees it. The wall is telling you because you're still throwing a distinctly shaped shadow on the wall. It is the sun that is causing that to happen. It's not twilight that's causing that to happen. It's the sun's physical presence. And that's sorry, that's why on the end of my video on BitChute, you'll see Dave Weiss's footage, which confirms exactly what I'm saying, that the sun is still there well above the horizon as it fades out. It is no longer dropping down. It has already done the dropping down thing. It's very close to the horizon, but it doesn't drop below it. It fades out.
Uh, can I ask you a question? I just came in. Uh, so I missed the. Can you hear me? Hello,
Yup, loud
can
and
you hear
clear.
me?
You come
Yeah,
Okay.
in.
we can hear
Yeah.
you, Hanson.
Yeah.
We can hear you.
So I just came in. I missed the lecture. So I was just looking at the uh, the PPT, the PowerPoint. Uh, is it? Let me guess. Is it the? I'm just looking at page. Oh, there's no page number on this. Um, so you're saying that if H0 is the globe, and if according to H0, the sun should uh, go below the, or I mean, at the horizon, and then going from picture A to B, that there's seems to be like a wall or some table, right, on the left-hand side. Should throw a shadow. The top of the shadow should be higher than the height of the wall or the table, right? The top
Precisely.
tabletop. Is that correct?
Yeah, when you're looking at the H0 on page 3 in the modeling to frame B, I believe that's what you're referring to, where the
Yeah,
pillars on the left
the
side,
pillars, right,
the
the left
top of
side.
that pillar, in terms of vertical height, the top of that pillar is the same height as the bottom of the opening of the window on the west wall, right?
Uh,
So what we're seeing is that the bottom edge of the sun is now below the
the
height of
pillar,
that pillar and
exactly.
casting an upward shadow. That's the
Yes,
globe model prediction. And
right.
that is not what we see in the data.
Okay, and then so according to H1, the shadow should the height of the shadow on the right side should always be lower than the top of the pillar, right?
And in my data, I'm actually helping you by an extra 16 meters of pillar, so to speak, 1,400 meters to the west of that opening. That I'm actually helping you guys try to achieve this effect by an extra 16 meters, which again, we never see in the data.
Okay, but the question is there a mountain that is higher than the pillar and some distance?
I'm not sure what you're asking, Hanson.
Okay, so what I'm saying is instead of a pillar, I'm just asking if your house is kind of in a plane rather than, let's say, there's a mountain to the left of the pillar and
Take
the
it down to page 5 in the PDF. Or
page 5.
I think that's page 5. Is that page 5? Yes,
Yeah,
page 5. The one
there's
that
no.
says the north
Okay, let me
with the
count. Let me
room,
count.
and then the
Okay,
one that
all right.
says west of my house, a road run along the ridge 16 meters higher than the window of my house. Do you see that one? It says 212
There's a
meters and
map, right?
228
There's a
meters.
map.
That's
Okay,
right. It's a Google Earth shot.
yeah,
Okay. So on the right, that's my house at 212 meters
right.
above sea level. And on the left, that is the ridge 16 meters above, 1,400 meters away. And in between those 2 points is actually a valley where altitude drops to 170 meters, some 42 meters below my window on its way back up to 228 meters. That the land itself in between those 2 points could not play less of a part in what we're talking about
Yeah,
here
no,
with
I just
regard to
want to know if,
obstruction, with regard to refraction, with regard to anything. It's
yeah.
totally out of the way.
Okay, so let's, the 228 mark, is that the elevation or what is the 228
Altitude of the
meter?
land at that point, 1,400 meters west of the house, in the same line at which we're looking at the sun from the window in the house. 252, and that's all in the ruler box. If you zoom in, you can read those figures.
Yeah,
But the
let me
heading
see.
says 252 degrees, and that the length shows 1,400 meters. That's the distance between those 2 points. And like I said, between those 2 points is a really deep valley. My house
Hmm.
is right on the top of the hill, to answer that
Okay,
question in
and
advance.
then the
Yes.
228 meter, is that what is this elevation or something?
Altitude of the land, right where that road is, right at the azimuth that we're looking at the sun, right? So we're actually,
No, no,
that's
no.
the 16
Can you
meters
just
you're
answer
seeing.
my question? Sorry, I'm looking at the map you have, and then there's a yellow straight line, right? And then supposedly on the right end of the line, that's your house, right?
12 above sea level. Yes.
Yeah, 212 meters. That's the elevation, the sea level above the sea level, right?
That is the
212
altitude of
meters.
my house. Yes.
Right. And then 228 meter, that's the point at the left end of the yellow line. There's a mark of a 228 meters. That's the height of, I mean, that point above the sea level, right? Is that correct?
Altitude of the ground, where that road is, and the yellow line, if you take your eye over to the right end of that line and you look along that line to the left at the 228, you will be looking directly at the spot where the sun approaches the horizon on an azimuth, on a heading of 252 degrees, which is 18 degrees to the left of due west at 270. You got all that?
Yeah. But then this left end of the line, that's the highest point. Um, the that's the reason that you mark it out is that this is the highest elevation in this vicinity. Is that the reason?
Actually, that is the thing behind which
Altitude,
the
altitude.
sun should disappear,
Ah,
but never
okay.
does.
Yeah, and then this line is the line of sight to the sun, right? From your house to the
You
sun.
got it.
This,
252.
yeah, 250. Yeah, that's the degree from east, right?
Azimuth, the heading, yes.
Yeah. Okay, and then so my question is actually the the highest in your experiment, the highest. I suppose that picture B, that is the before sun disappears, right? But I mean the whole red ball disappears. That's the last
Which picture
angle,
B?
right? That's the H1. That is the last moment. I mean, that's the highest point that the top of the shadow of the pillar, top of the pillar, throws on the wall. That's the point, right? The
At H1,
one.
you're referring to page 4, the page before the one with the
One,
Google map on
two.
it?
Hold on. 1, 2, 3. It's better if you mark it with numerical number. Page one,
Well,
two,
just check your.
three, 4. Yeah,
It
4.
should show in the bottom of your window what page you're
Actually,
on.
yes. There's a 4 of 10. Yeah. Okay. So
Yes, there you go.
yeah. So yeah. So B, that that shadow is the highest point
No,
that below the window, right? I mean the
no,
on the
it's
red
not.
wall.
Take a look at C and D, which are nearly the same. That
Okay.
you see that the pillar shadow is
Mm,
coming up to the sill of the window, but never gets there, right?
okay.
That's
And
the
then
difference between the two models.
so the thing is okay. Did you measure? So it just stays there and then darkens the whole thing darkens right afterwards. Is that right?
Ambient light is always going darker and darker and
Right.
darker. And this is,
Okay.
again, this is a difference between the two models because we're talking
Yeah,
about
yeah, no, I'm just
the
trying to
opacity
understand
value
the whole
of
thing. Yeah, no,
air playing a
mhm.
factor, right?
Yeah.
It's
So
a
That's not
difference.
actually
let's say, let's say, did you measure the, let's say is the height, let's see, the height, the top of the shadow, however, it fades away, and then the top of the shadow and the top of the pillar, is that, um, this is like, did you measure the angle between them with respect to the horizon?
Okay, Hanson, it's really too bad that you didn't show up on time. I gave you an extra 25 minutes to get here. And what you really need to do to answer that question is take a much closer look at page 8.
Page 8.
Yeah.
Okay.
It's got the big picture of the wall with all the pink X's on it underneath. And it's got a
Yeah.
big red dot on the wall with a 117 millimeter. That's the measurement that you're looking for. What we're doing there is the red magnet is actually that's just a round piece of plastic rather, with a magnet glued on the back of it, and it's stuck to a steel isopanel wall. And the center of that magnet is exactly the same vertical height as the bottom edge of the window through which all of this light is shining on the west wall. We are
Mm-hmm.
looking east in this picture, right?
Mm-hmm.
So what we're looking at is that even as the sun is fading out, and in less than a minute from completely fading out, it still never comes closer than 117 millimeters below that
The
height.
top of the
That
pillar,
means that the
right?
sun never comes down low enough, you know
Yeah.
what I mean, to make the shadow go above that or anything
Okay.
outside either. Remember
So
that ridge we were talking about, Hanson?
yeah.
That ridge is 16 meters higher than the magnet. And still, the sun, which is supposed to have the same brightness all the time because it's the same distance away, 93 million miles all the time, as it's going down at the same rate of descent all the time, according to the Globee model, we do not even see that 16-meter ridge casting a shadow through the
well,
window
well, well,
on the
man,
wall here higher than the magnet. We don't see anything of the sort. And that's the
that
answer to your question.
yeah, but that's why you need to accompany a video with that shows the angular height of the sun above the horizon, right? Because
Why?
if you look at the
Coffee.
video posted below, civil twilight corresponds directly with what you provided.
If you go to BitChute and you watch my video that I put out on this subject last week, the last few seconds of the video are footage from Dave Weiss, who took his own drone up to the top of this big tall hill while his buddies were still on the beach and had already seen the sun go down, quote, where he sent his drone up another maybe 150 feet or whatever it was, filming west. And it shows you the sun still well above the horizon, fading out into nothing. You see the
I linked it in
entire
the chat, by the
round
way.
the round piece of sun It's right there, and it absolutely confirms everything we're observing here and measuring here.
Yeah, sorry, I didn't mean to interrupt, but I did link the video in the chat.
So the bottom half of page 8, both Hansen and Coffey, you guys need to pay particularly close attention to. The difference between the green figure and the red figure. That is the space in the sky where the sun still exists as it is fading out. It's what of the sun that I can see over that 16-meter peak to the west, 1,400 meters away, and the top edge of the sun, which is producing the bottom edge of the shadow on the east wall, which never comes closer than 117 millimeters to the magnet, the center of the magnet. That is what produces those two figures, 0.995, 0.655 degrees. That shows me the angular size of the portion of the sun I can still see if I were using my own eyes and my own camera to look out to the west as the sun, quote, sets, only it doesn't. It stops going down and it just fades out. And we can still see 70% of the sun while I'm recording this data as it fades out above the horizon. That is the geometric truth of what we're looking at right here.
Yeah, yeah. So before, I mean, because I can do the computation, but then, oh wait. So page 8, you have this the diagram below the picture with the magnet, right? And
The little
red
gray
dot.
box. You got it.
Uh,
Peak
yeah.
on the left, wall on the right, door in the middle, 1,400 meters
Door.
versus 7 meters. The
Yeah.
door is the
So
window, right?
door is the
It's
window,
the
and
window in
then
my
where's
door.
the pillar? Sorry, where's the pillar in the
The pillar,
diagram?
in my case, the pillar is the peak, 16 meters above. The peak is not the same height as the window. It's 16 meters above the bottom edge of that window. You know what I mean? I'm trying to hand you, I'm helping you guys
No, 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 no.
try
Okay,
to
just
produce a shadow
wait a
on the
second.
wall
I
as the
just
sun
trying to
goes down.
understand the diagram. Don't explain,
I'm trying to help you
overexplain because
explain the
I'm,
diagram.
yeah, yeah.
I'm
Don't
explaining the diagram to you.
because
This is what I'm
I
saying.
want to know where the pillar is. The top of the pillar in the diagram, is that the door thing, or where is it? Sorry.
Listen, clear your mind. When I'm taking this recording at my house, there is no pillar right outside the door like the model. There's something better. There is something more pro globy than that influencing this data, or frankly, not influencing this data. That the pillar outside the house in the model is the same altitude, is the same vertical height as the bottom edge of the window. In this example, in the real world example, I'm showing you the equivalent of that pillar 1,400 meters away, 16 meters higher than that. And still, we do not see the shadow produced from the sun hitting the ridge, going through the door onto the wall. At
Okay,
no point do we
wait.
see anything of the sort.
Right. So you
Yes.
just one, right? I just watched the video, right? It doesn't show me that video of the sun doesn't show me who took the video, right? I'm talking about the
About
observation from the position of the light shining through your window. Is that direct sunlight?
direct sunlight. You know how it's direct sunlight? You can see the actual shape of the window on the wall. It's being shot directly through four triangular pieces of glass. This is a very common door window you can buy at Home Depot or just about anywhere on Earth,
Yeah.
But
right?
if I
That's
looked
why.
out that door window, would I see the sun? This is what I'm asking you.
Would see an angular size of 0.34 degrees, vertically speaking, of the sun. You would see 70%, or even slightly more actually, of the entire sun as it fades out. It does not keep falling. And that is what the graph shows you as the black line departs away from the slope of the blue line. Is what that means is the sun is not going down at that same rate anymore. It's not going down at all anymore at the moment it's fading out.
No, that's I get all of that. All I'm trying to know is if I took my two eyes outside that window that's shining the light in, would I directly see the sun with my own eyes? This is what I'm trying to figure out here.
I just said you would see slightly more than 70% of a refracted, compressed vertical angular size of the sun fade out. You would be looking directly at the sun for all of this until you just don't see it anymore because it can't get through the air that's in between you and it anymore.
So why didn't you just record it from the actual window of the door? That would have been more
That
easier to
is
understand.
why that is why I put Dave Weiss's footage on the end because that is what you would see.
No, Dave Weiss's footage is cool, but I don't know where he's taking that from. So it doesn't hold no bearing to this
Thinking about
observation,
where he's
right?
taking it from. I
I
just
would have
told you where
liked to
he's taking
see
it from.
I would have liked to see the observation of the sun through that actual door window. That would have helped.
No, no, it wouldn't. No, it wouldn't at
Because
all,
it would
Coffee.
give me an understanding if it's civil twilight, right? If that sun is actually visible and is direct sunlight shining through that, because you could get the same correspondence during civil twilight. This is
If you
what
were
I'm trying
paying
to point out
attention,
here.
Coffee, you remember that I mentioned my north window. That is the influence on the entire wall in terms of ambient, quote, twilight, quote, you know what I mean, background lighting and how bright the rest of the sky is. That's what you're seeing on the entire wall. What I'm measuring is the light produced strictly by the sun and the angular inference we are to take as we take these measurements.
Yeah, that still didn't tell me nothing, right? Because the light shining through the window directly on that wall corresponding to the actual shape of the window, right? If it was twilight, that would still be brighter than that ambient light just
No,
bouncing off
if it
your
was
walls.
if it was just ambient light, you wouldn't see this at all. And that is exactly what you see after the sun rather is done fading out. All you see is the ambient light on the wall.
So
You don't see any of the shape
there's three
anymore.
phases of twilight, right? There's civil
Completely
twilight,
irrelevant to
nautical
the
twilight, and
analysis.
astronomical twilight. Astronomical twilight is the point where it's actually night, where the only shadow casted is by the moon, right? During nautical twilight, there's
Skill
still
testing
a
question, Coffee, skill testing question. At that moment in astrological or whatever twilight, where's the sun?
the sun is between, I believe, 10 to 15 degrees below the horizon.
It never did slow down. It just kept going down below the horizon in your model,
Yeah, that's
in
the
your assertion.
correspondence to our
Okay,
model.
so then
So
as it's doing that, its brightness doesn't attenuate at all, is what you're saying, right? In your
no,
model?
I'm not at all saying
Okay,
that.
because it's
But
always 93 million miles away, right?
hold on, my brother, let me finish. Don't collapse here. So during civil twilight, right, you have a dip in brightness that only corresponds to about 1 to 10%, right? This is how much of the sunlight is still shining over the horizon. And then you have nautical
That it went
twilight.
below the horizon, right? It's down below the horizon. You can't actually produce this kind of shadow on the wall through a window anymore with
Civil
such
twilight, you could
definition. Why are you interrupting me? I let
civil
you talk.
twilight, you can still
Why aren't you
produce
letting me
that
talk?
shadow.
Why aren't you letting me talk? I let you talk. You let me talk. That's the deal, right? Okay? We got an agreement? You gonna let me talk? You're telling me that the sun's rate of descent never changes because the earth is allegedly always spinning at the same rate. The sun is always going down at the same rate. We should see that on the wall. We should see because during that time, the sun doesn't get any darker. The sun always burns as bright as it burns as bright because it's 93 miles a million miles away, right? Okay, great. Well, if there's no change there, then according to your model, just like I showed in the first half of this document, according to WJB's model, shadows should be produced by the physical obstruction of the earth, specifically that peak 1,400 meters away from my door, where the sun should strike an eclipse and backlight that peak and cast a shadow through my window on the wall. We do not see that. We see the opposite. of that.
Yeah, and I think if you're appealing to like the ambient light and not it being, and it not being the direct sunlight, I think you wouldn't get that crisp, you get a really diffused, really spread out. I don't think you would get that
You're right.
defiant arch shape at all. You would just
You
get it
wouldn't
really.
get it at all.
Yeah, that's
All
what
you
you.
would get is what's coming through the north window because it's closer to the wall.
Yeah, that's what you believe, but you got to do some research, right? Anybody go
I
get
believe I'm
online
showing you
and
the
look up.
empirical proof.
Hold on, you gonna let me finish talking now? You gonna cut me off? That's what we're doing now? Okay. So all you got to do is go online, look up civil twilight, right? Look up nautical twilight, and look up astronomical twilight, and look at the differences between all three, and you'll see all the questions you have answered.
Questions, and all three of those terms are completely irrelevant because they take place after the sun has, quote, set, after we no longer see any direct light from the sun,
Incorrect.
which
So it
would produce, see,
corresponds.
you're interrupting me, buddy, which would produce this shadow on the wall, which would produce a clearly defined shape of the opening on the wall. We do not see any of that. So twilight is irrelevant to the
Did you look at
analysis.
the video I posted? Tell me
I've
where
been
the
busy
sun is in the
presenting.
video I posted. Tell me where the sun is and what you're seeing. I promise you it looks a lot like Dave Weiss's video.
It's 3 minutes. Give me a sec to watch it. Okay, first off, the guy's on the beach, right? Apples to Winnebagos.
Where's the video? Sorry, who's saying that? Probably it's in the chat, but which one is it?
17 minutes ago, Coffee dropped it. It's right above the link of Jose's. 17, 18 minutes
And
ago.
and frankly, it doesn't show 20 minutes of data like mine does. Okay. It shows the last minute when you're way down on the water, where refraction does indeed play a great deal of influence into what you're seeing in the apparent position of the sun, its vertical height, its total angular size, and how it disappears into the horizon deck. There's a bunch of clouds all over that video. This could not be less resemblant of the data I took. It could not be less relevant. Who's hot micing?
Man, is
Marcus
that not
Party? Somebody want to mute up Marcus
civil
Party?
twilight?
Oh,
The
yeah.
hell?
Hold on. I got it. Give me a second. All right. Go ahead.
And several things wrong with this video, Coffee. One, he's shooting it at the beach, just like I mentioned that Dave Weiss did not do. Okay. His buddies were down at the beach while he was up at the top of the hill and then sent his drone up from there to get the correct vantage point on the sun so that none of the other parts of that atmospheric deck come into play. Precisely what I'm doing in my own observations here. Your video could not be less relevant.
Yeah, I think that was pretty relevant, but it's cool, bro. It's cool.
Would you like? It's absolute bullshit.
How is that video relevant?
One, no, try and give me one constituent of that video, one parameter that resembles anything of the observations and measurements that I took.
Well, for one, it shows the level of brightness still apparent in the sky after the sun dips below the horizon at his
And mine
level,
doesn't.
at his position on the beach. So if you're higher, right, you will have to deduce that that sun is angularly lower than his position than it observed at the beach.
Nonsense.
In that case, wouldn't have produced that hill that was higher outside of Stones. Wouldn't that have shown in his shadows?
16 meters that are above in the way on the sun's
Correct.
way down. We don't see it.
Right. That's what I'm saying. That would have appeared on your window if that's the case.
Than that, guys, I actually took the measurement of the 0.995 degrees that indicates the top edge of the sun, the least distorted part of the sun, at that elevational angle above horizontal, still in the sky as it fades out. We are physically looking at 70% ish of the sun physically producing a sharp image on the wall because it is direct sunlight. It has nothing to do with twilight. It is direct sunlight coming through the window and producing a sharp image of those four pieces of glass on the wall until the opacity value of air exceeds the limit for that radiation to be able to get to us. And then what you see on the wall is nothing than what's coming through the north window, which is a very big window. It's like a meter by a meter and a half, right? And that ambient light is still on the wall, still getting darker, still getting darker, still getting darker. They are entirely different. And Coffee's little video is utter nonsense if you're trying to make any kind of comparison about anything.
Yeah, so if you do your research, right, you just understand that during civil twilight, the sunlight is still being scattered through the atmosphere, so you can still get that appearance of direct sunlight. It's totally plausible.
Coffee,
All you got to
coffee.
do is just
I
do a little research. That's it.
Dude, I have no idea what makes you think it's a good idea to try and gaslight me that I don't know what twilight is. That is a joke.
I mean, do you have an actual refutation, Coffee? Or are you just saying, look at this Twilight video and how it's not analogous?
No, I'm just saying that he's corresponding this prosody that he has to this fading of the sun, and I'm like, nah, it's just twilight. That's all it is. We all see it. Like, simple shit.
Just hand wave dismissal. It's just Twilight. That's all it is. That's all it is,
So,
guys. We can go home. It's just
okay,
Twilight.
coffee. So, like tomorrow night when you're here and I'm not, are you going to be telling people that you cooked me again? Is that your MO still?
No, I mean, I said from the beginning. I said when I first got
He
on
is
here that this was gonna be
1000% gonna
easy.
be saying
This
that.
is gonna be
Let me
100%
tell you,
easy because it's
he
twilight.
Expect
he
him.
is
Expect him tomorrow night, gentlemen and
he,
ladies. You will see him. Oh yeah, I was cooking stone last night. Wait for it. Wait for it.
Yeah, no, I said it when I came in. I ain't gonna wait till you're gone, bro. This was easy.
Nonsense. Does anybody else have some questions or something to clarify or any comments? Anybody else?
I'm sitting here like trying to play devil's advocate and like be Glober in my
Oops.
head for a little bit, and
I
yeah, I'm not like okay. I don't what I don't wouldn't understand is the slowing down also of the of its ascent. It slows down. What would account for that on the globe as it
Exactly. What would you see in the globe model that would cause the sun's rate of descent to change in any way? And the answer is nothing.
Are you using a direct observation to tag this slowing of the sun, or are you using the light that you're
God,
staring at from your wall?
look, I
Well,
If you're
that's what
measured
I'm
it.
using
saying.
the
The
I
light that
ascent
you're
of
graphed it.
that
staring
What
thing
are
at
you
up
from
the
your
talking about?
wall.
wall, right? Between, I think, B and D, right? You're probably viewing the scattering of sunlight and not direct sunlight. There's no
That
way
is
of
the
knowing. This
case.
is why I said you should have took observation
Well, I think
through
in
your
truth,
Again, I'll
from
say
window.
it
the way
again,
that you
If
coffee.
would,
you would have took the
Hey,
observation from your
coffee,
door window, we could have got
coffee.
an
Yo,
understanding of what you was looking at.
yo. If there was any change in how direct of the light coming from the sun would be, if there was any change that it was any less directly from the sun, then the crispiness of the image on the wall
yeah,
produced
that's the thing.
would also go fuzzy, and it does not.
That's not correct. You have to look up civil twilight and the shadows that correspond to it. I can't say no more to
Coffee.
that.
Again, twilight is what happens when there is no more direct sunlight to be seen.
I
It is
know, man, but
irrelevant
like I
if
said
a
before, the
twilight,
sun could
hey,
be
coffee,
scattered through the
yo,
atmosphere,
coffee,
giving you the
yo,
appearance
coffee,
of direct
yo,
sunlight.
yo,
Hold on,
yo,
y'all. Hey, we can't talk
coffee,
over each other now. Go ahead, son.
coffee, yo, twilight happens after the sun allegedly passes below the ecliptic. Okay, it happens after. And in my data, that is what you see. You do see some twilight shining through the north window on the wall. And that is also what you see slowly getting darker over the 25 minutes in the second recording. You do see the effect of twilight through the north window on the wall. The ambient light change that is there as well. But what we're measuring is the direct line of sight from the sun through the window to the wall, producing a nice, crispy shape.
Hey,
Got
yo,
that?
Yeah,
if you think about it, intuitive, like being from the city, bro. I know you're in apartments. Oftentimes, like you have the experience of watching as that sunset, dusk hour, and like the sun will set behind the building long before, while it's still high in the sky. Maybe if you move over a block, you'll still see it. But the second that you'll see that cutout coming through the window, that direct shape plastered on the wall, and the second that that sun moves or like sets behind the building or something, that shape is no longer there, even though all the ambient light is still out and the sun is still up well above the horizon. The second that you don't have that direct sun coming through the window, you don't get that shape anymore. You don't get, there's ambient light still around, but even if that sun just sets behind the building, just for a few seconds, that shape goes away on the wall.
yeah, not for me, bro. I'm gonna try to record it tomorrow so I can have some better proof. But usually, when
I
the sky is
double
glowing
dog dare
gold,
you.
you gonna let me talk, bro? Okay. So if the sky is glowing gold, I get a gold shadow through my window in the shape of
Yeah, it's
my window.
highly diffused. You don't get a sharp, any type of like crisp edge at all. Like it's
The crazy
highly
part, it
diffused.
looks like Model D between February and November. It looks a lot like that.
I don't know. I
I
guess the simple fix,
coffee.
like to take your criticism, I guess the simple fix would be just to put one more camera on the camera, like facing the camera and the window out. If you
Yeah,
could
I
figure out some
suppose
way
to
to
have a
do that.
camera also on the horizon might have keyed it in. But that again, that is why I tacked on Dave Weiss's video because that is what you would see if I had also done that. The point is I didn't need to do that. I was already taking direct measurements of the effect of that on the wall.
Yo, did we already cover how twilight makes the sun set 70% above the horizon or what? I'm not sure I get that.
Civil twilight counts when the sun touches the horizon and goes hits the 6 degree mark below the horizon. And then after that, you hit nautical twilight.
All of that takes place minutes after this observation is done.
What causes the slowing down of the shadow then, Coffee?
Well, you're not going to see no angular change in the shadow if it's not direct sunlight. If it's just sun scattered in light scattered in the atmosphere, it's not going to change angularly.
It's not scattered sunlight for the 15th times direct.
Yeah, I don't know that, bro.
Well,
At
for
it.
sure, if you're like if you're tracking it and you would assume that it started as direct sunlight, surely the second like you it'd be pretty discernible difference between when the sun directly is creating that shape versus when the ambient light is creating that shape. I'm sure there'd be a marked difference that you could notice in like a few frames or a few seconds of watching that.
That's why I asked them, right, for the video of the camera shining through the window, looking through at the sun, because during civil twilight, right, when the sun is touching the horizon and it dips below to that 6 degree mark, there's not that much discrepancy in the brightness. You still get
Is
that
there
damn
any
near
data on
orange.
that? Is there any data available on like what the luminosity, what the ambient light is looking, in
Yeah,
terms of luminosity?
But either way, what you're basically saying is you will concede your twilight argument as if Man in Stone had a camera facing the horizon with the sun. So you're basically calling into question his experiment. You're saying that's not direct sunlight, correct? So if he provides a video with direct sunlight and the same exact thing on the wall, you'll shut up then, right?
I will have to, obviously.
All right, cool. You hear that, Stone? There you go.
One more
Gentlemen,
time, Stone.
That'll
what
be a
we,
good backhand. Like, shut up, nigga. There you
ladies
go.
and gentlemen, what we are witnessing here is cognitive dissonance in textbook form, in action, live before your very eyes.
Hey, so coffee. Um, if if this is done to your satisfaction, will you be willing to concede that the sun doesn't go down and indeed just goes away?
No, I can't concede that much. I will concede to the
So
fact
wait,
that I was
wait, wait. So
wrong.
what's
Hold
the
on,
point of
hold
him
on, my
showing
bro. Hold
you?
on. I will concede to the fact that I was wrong about my criticism of Stone's presentation, and whatever it could be may be over my head.
Yeah, like the sun's over your head. Yeah, got you, bro. So,
Right.
so let's just say that it is direct sunlight. Do you have any other rebuttal or refutation other than civil twilight? Because that's not a good rebuttal, to be honest, bro. It's just hand wave dismissal at that point.
Yeah, if you feel that way, that's cool. Don't bother me.
No, the question was, do you have any other rebuttals besides
Nah,
that?
no, I honestly don't. That was my 1-2 punch.
All right, cool.
I hope you still
Good plan.
standing, Stone.
So again, if that's the only rebuttal you got, then all you're going to say is, well, it's a globe, but it's something that I don't understand, so I'm done. That's all you're going to say?
No, I'm gonna say let me look more into it, and I might have to get some. I'm gonna have to do some research or get some advice from some heads over me. And if I can't come to a conclusion there, then maybe you got it. But if not, then
At the
your journey's
beginning,
still on.
right at the beginning, the word I used was replicable. No special tools nor instruments required. I double dog dare you, Coffee. Go ahead and record this yourself, doing with the same parameters, and show me that it ain't so. Go ahead, buddy. Give it a shot.
Either way, that doesn't explain why the actual shadow doesn't go to the magnet, doesn't go and level out with the magnet. Why doesn't that happen? Why is it slowing down, and why doesn't it go level with the magnet? Those are
Exactly.
my two questions. Forget about the luminosity. I guess if you have that contention, which I don't agree with, so what about those other two questions?
We
Well,
see
if
that
there's no
16
longer
meter peak shadow on the wall. I handed it to you guys, an extra 16 meters of variable in the experiment, in the observation. I gave you an extra 16-meter obstruction. Why don't we see that on the wall?
yeah, if the shadow's no longer being guided by the direct sunlight, right? And it's being guided by this scattering light in the atmosphere, it's not gonna level out or even move.
Coffee, the brightness of the sun in the Globee model never changed, right? It was supposed to be as bright as it always is because it's 93 million miles away, right? And it's just going down. It's just doing its thing across the sky. The fact that it hits the horizon, that don't make no difference, does it? It's still just as bright. Why doesn't it actually produce a shadow of that backlit peak on the wall through the window? Why don't we see that?
Now, man, I'm gonna give you more credibility to that and believe that you understand the globe model explanation for this dip in intensity of the sun's light when it gets close to the horizon. I'm just gonna assume that you know this because you seem like a smart man, my guy.
I don't really know what that means, but according to the text chat, Bert appears to have something to say, so maybe we should shift focus to him.
I was going to ask real quick, Bert, did you have something up in here, bro? Oh, there go Bert. Yeah, that's Bert. Go ahead, Bert.
Hey, how you doing, Stone?
What's
hear
up?
me? Hey, nice to meet you.
Yeah, yeah, I hear you.
I appreciate your presentation and your overall demeanor presenting it. I like the pursuit of the measurements and how you plotted them out and such. Bravo.
Many
Um,
thanks. That's great, man.
yeah. Hey, not bad from a Glober, huh? Um,
Mhm.
so I listened when you first did your presentation. I have a few quick comments and then maybe some questions. Okay. One comment is that the null hypothesis is not how science is done. I'm just going to say that in terms of the scientific method, what you seek to do is you seek a hypothesis where you say, I observe something, I hypothesize this, therefore I'm going to calculate, model what I expect to see, and then I'm going to do an observation and see if I see it. And if you see it, then you say, that fortifies my model. And if it doesn't, then you say, okay, it discredit my model. There's something wrong with my model. Either it's completely wrong or I have to modify and let's try again. So it's not a null hypothesis. If this, then it's true, and if not, then it's not. Then this other thing is not true. That's my first comment.
Wait, so once you get a
Put that
research result,
first.
what do you do with the hypothesis? Do you accept the hypothesis or do you reject the null?
So there is no null, is my
What?
point. So in other words, it's not an A or B. You're testing A, and you can say, okay, my observations either support A, in which case I'm going to
No.
continue to refine A. I'm going to continue to come up with other experiments to test A against A, or it fails and you say, okay, I either have to discard A completely and try something else. But
Let me address that.
what it doesn't do is it doesn't say, okay, there's only two options, and if it matches A, then B automatically cannot be. You have to kind of like do your own
Okay.
separate hypothesis for
Okay.
B,
Not
right?
true.
Let me address
That's
that.
not true either.
Sure.
Go ahead.
Let me address that. So A being the globy, saying that one's revolving around the other, one's spinning, whatever, and B saying there is rotation above a flat. Okay. So when you said that's not how science is done, that's exactly how science is done. It is the logic behind why the science is done that way. Okay. Further, you see, I wasn't just chipping away at one of them. I was chipping away at both of them. You see, the data that I present here tonight both negates H0 and confirms H1. Empirically so. There's no conjecture, there's no additional hypothesis, there are no other controlled variables to change. There is nothing else to talk about because both are being handled by the empirical evidence that
Okay,
we're
I'm not
looking
sure if
at
you
here.
understood what I really meant, though. What I'm saying is you have independent hypotheses for the two, and null is not how people in science do science.
You're
They have
tripping, dude.
independent separate ones. No, and I'm not
Out of your
putting
mind,
down. I'm
Bert.
not
Next
putting
next
down that
point.
you. I'm not. Yeah,
Next
I'm
point.
not. It was like I said. It was just a comment. I'm not putting down the fact that
Totally
you did
incorrect
put the
and
work
whack
into.
comment. It's an ignorant comment, Bert. But by all means, what else you got on your slate there?
So I didn't come here to insult you. I'm not calling you ignorant. I'm not calling what you did
You're just wrong though
stupid.
about the null
I'm
hypothesis.
talking
Just move
about your
on, brother.
comment, Bert.
Yeah,
Can you
just
hear
move
the
on.
words I'm using? I
I
said it's an
absolutely.
ignorant comment. Can you
Okay,
hear that?
so I am not ignorant of science. Um,
You didn't answer my
it,
question
Saying
though.
is telling me you
it
are.
was it was a comment, and we can move on. That's fine. But my point is, I'm not here to insult you, and I expect maybe the same courtesy, if that would be nice.
Okay, you either
So,
reject the null or you fail to reject the null. You don't accept anything. So that's how scientific method works. You don't say, "Oh, I accept my hypothesis." You either reject the null or fail to reject it.
no. You either say
Oh,
it
really?
verifies my hypothesis.
Oh,
In other words,
really?
science doesn't seek to say I absolutely prove something. It says I'm on the right track
No, I agree with that
or
statement,
not.
but you don't accept the hypothesis. You either, like I said. Reject the null or fail to reject the null. And if you don't know that, just do a little bit more research.
Again, it's not like A or B. It's you're dealing with one thing at a time. But I do like the fact that you did the H naught and H1. That's fine. Now when I see the globe presentation where you have the rising shadow that kind of cuts off the window from the bottom, that's great if you have a completely unobstructed ridge and it's not too far away. Otherwise, the half a degree angular extent of the sun would cause a very faded out shadow line, not a sharp shadow line. And you would just simply see the sun fade away as opposed to a bottom up sharp shadow. And so I'm not sure if you calculated what that would be from 1,400 feet
What distance do you think is
meters.
going to qualify that? Is 1,400 meters not good enough?
No,
Does it have to be closer? Like, what are you saying?
right, right. So if you want a sharp shadow, like if you have any extended source like the sun, whatever, and you hold up a sharp edge 1 meter away, you get a nice sharp line, right? If it's 5 meters away, it's less sharp. If it's 10 meters away, it's less sharp. If it's 100 meters away, it's starting to really fade, get fuzzy. At 1,400 meters away, it would be pretty fuzzy. And as that fuzzy line starts to cover the window, it would be more of a fade out rather than a sharp blockage from the bottom up, the way you just depicted it. So, like when we model stray light in optical systems, we're looking at how light falls and diffuses over a scene. You wouldn't get a sharp line like that from 1,400 meters away from a half a degree source at
So,
distance.
what is the line? What is it? What's your limitation on that? Where does it have to be? You know what I mean? I mean,
Well,
what we're
there's no
talking about
limitation.
here
It's a
is
it's a it's a it's a continuum.
in between the door and the ridge, there's this giant valley. So there's absolutely nothing other
That's
than
fine.
those two elements
Understood.
in it. So even though it might not be an absolutely crispy line because it's not right next to the door, how come we don't even see a fuzzy line shadow coming up higher than the door? You know what I mean? We don't see any of that. It's always a crispy, well defined window shape on the wall until that minute when it fades out.
No, I'm not talking about the shape of the window shadow. I'm talking about the line on the outside of the building. So, like when you have C and D, and you have the shadow of the distant ridge creeping up the side of the wall, it wouldn't be a sharp on-off line. It would be a blurry going from dark to light. Does that make sense?
You're making sense, but you're not making a correct point. And that's why I put Dave
Well,
Weiss's
I'm not
footage
sure why it's
right.
not a
Hey, Bird,
correct
I'm
point.
talking. And that's why I put Dave Weiss's footage on the end of my video, because that really is what you would have seen if I had an additional camera pointing in the other direction, watching at the sun.
Okay.
That's what you would have seen.
Okay. All right. Good. And there's just one other thing I'd like to clarify. Is it fair to say from your presentation that you believe the lights in the sky tell us about the shape of the floor?
If you've got any other relevant questions to what I present, by all means, ask them.
No,
So far, I haven't heard
it,
any.
no, it's a serious question. So I'm just clarifying that the movement of the sun and the way it casts shadows confirms for you the shape of the Earth. Is that a correct
If you
statement?
have any relevant questions that actually pertain to the evidence I'm presenting, I'd be glad to entertain them.
Okay, but again, I'm just asking that question. Is that a
You
yes?
can stop asking that question because it's not germane to the conversation.
It is kind of the whole point of your
Stop trying to
presentation,
get a
isn't it?
got you, please, and just move
Well,
on
do you
to
have
a
other got
relevant
yous that you want to
Okay,
question.
fire off, or
fair enough. All right. Have you? It's good that you did this measurement, and I like how you noted that the shadow slowed down at the very end before setting. But have you ever done any actual direct angular position measurements of the sun as it's setting, like using a solar filter and then tracking it angularly, um, as opposed to watching the shadow? Because
That is
it's
why I put Dave Weiss's footage on the end of my video on BitChute, because it shows precisely what you're asking for here.
okay. He didn't measure the actual angles, though. I'm just asking if you've done this.
I did measure the angle. That's what the graph on the bottom of page 8 is all about. At
I'm sorry. Let me rephrase.
0.995 degrees, right? Upward through the window, 0.995 degrees. And at 1400 meters away, that comes to 24.3 meters above the bottom edge of the window. This is
Right.
defining the top edge of the sun as we still see it in the sky.
Well, it's the light source as an average disk is where you're measuring, which is good. Of course, as it goes over the ridge, that average starts to slow down because if, let's say, the sun is half blocked or mostly blocked, then the average is still just above the ridge for a few minutes,
Now, what would
a
be
couple
blocking
minutes
the
as it's
sun?
doing that.
What is it
The
exactly that would be blocking the sun? It's the ridge, right?
correct, yeah.
And if that is a fact, and the sun never really does get darker, it just goes below the horizon, then the nice bright sun, 93 million miles away, would be backlighting that ridge exactly the way you would see, like the Canigou observation. It would be backlighting that absolute shape, and we would see that backlit, nice, crispy ridge coming through the window and onto the wall, which we never see.
Yep.
So that's not quite what I was talking about. I was just talking about the average centering
Exactly
of
what
the
you were talking
sun.
about, Bert.
Well, no, because now you're talking about the opacity. I think you called it the strict opacity value for air.
Yeah, well, air
And
has an
so,
opacity value. Are you going to deny that?
okay. No, not at all. So, like, I'm curious, did you also measure the intensity of the sun during sunset?
He told you what
Pyrometer.
he measured.
I
No,
just
no.
told you at
In other words,
the top of this presentation, I said this is entirely replicable with no special tools nor instruments. Got that, Bert?
yeah, that's fine. I'm just asking, did you actually? You were
What
talking
is
about
the
how the
relevance
sun
of that?
fades.
What is the relevance of that, bro? It's literally
Well,
just
it's
direct sunlight and a shadow being
right,
casted on a wall through a window, and the
right.
shadow doesn't go higher than the magnet.
So this is kind of like what I was talking about at the beginning. Again, I'm trying to have a conversation. I'm not trying to be antagonistic here at
No,
all.
no, no. I just want
And
you to have a good reputation because so far you haven't had one.
well, I'm not worried about my reputation. I'm asking,
No,
trying to have a conversation.
refutation,
Not with a P, with an
refutation.
F.
Oh,
Yeah.
reputation. Gotcha. Um, so, in other words, when I was talking about having hypotheses, so given the strict opacity value that you referred to for air, then the question is on a flat Earth and on a globe, what equations would you use to calculate what that a reduction in sunlight intensity would be, and how would you go about calculating that? And did you calculate that for both the globe model and the flat Earth model and compare it to your direct measurements of
Wouldn't.
the intensity of the sun?
I wouldn't calculate that. I would observe it as we are here instead, and I would measure the angle at which the opacity of the air overtook the limitation of the radiative output of the sun. And that is exactly what we see in the data for both observations.
I would definitely calculate that. That would be worth calculating, and then
Go ahead and present
for
your
the two
figures, Bert.
models.
Be a pretty
I
hard
can't
thing
wait
to
to see
pin
them.
down, no?
So,
Can't
well,
wait to see them,
Across
Bert. Go
hundreds of
for it.
miles.
I
Have you got a
I, bel
barometer?
I believe you said there is a strict opacity value for air. Is that correct?
Not a barometer, Bert.
I'm saying if you have a strict opacity value, then do you have equations that you would use to then calculate what that attenuation should be, both for the flat Earth and the globe?
Then,
And
Bert, now answer
why?
my question.
What? And so then why would it not fade out for a globe, but it would for flat Earth? Is kind of where I was going when
Because
you
the
said that it doesn't.
distance doesn't change in the Globee model. The distance is always 93 million miles away in the Globee model.
Okay,
That's
but
why, Bert. Now answer
so
my question. Do you have a parameter? Do you even have the
no.
capacity to do what you suggest that I should do and that you think
Right.
you're
I
going to
wonder how
do?
would
Do
you
you
even
have a
go about
parameter?
doing it?
So again, I'm not trying to be snarky, and I'm not like
The
throwing
no.
some gotcha at you. I don't have a parameter, no. But you said that air has a strict opacity value, and I agree with you. We know what the opacity of air is. I'm curious if you're missing a certain point here. In the, I'll use your own words, Globe model, you realize that even as the sun is a distant light source, that if it's coming through the atmosphere, which is really only in the last, the 10 miles above us, where there's thick enough atmosphere for absorption, that the difference between a high noon sun coming down 10 miles and a horizon sun coming in horizontal to the horizon would be going the difference of a few miles of air versus about 250 miles of air. Do you kind of understand that geometry for the Globies model?
And that's why I took the time to compute the angle produced by the shadow when we are still seeing a clearly defined shape on the wall, which is indicating to me, to us, that a great deal of light is still coming from the sun at that point,
Correct.
such that we don't need to compute the attenuating radiation because of the opacity of air. It is merely a matter of before and after. And as you plot those 2 points, before and after, what is the rate of descent of the sun? And that is something we are measuring by watching the shadow progress up the wall and then slow down and stop and then fade out. You see,
Right.
that is what clearly makes a hardcore cut it with the knife distinction between the two models and what you can expect to see in the observations plural that I present. This is why I said back at the beginning when you were
Hmm.
talking about this is not how science is done, that not only did I negate the Globe hypothesis, I confirmed the flat earth hypothesis with the same data. I did both.
Yeah, you didn't understand the point I was making with that, but that's okay. Um, so also, you also referred to the atmospheric compression with the sun getting um, compressing vertically. And I think that what you were saying is it doesn't compress horizontally. Is that correct?
Said early in the presentation, lateral movement of the sun is not relevant to the analysis.
No, no, I wasn't talking about lateral movement. I was just talking about the observed width of the sun. When you did say that compression happens
Width,
vertically.
lateral, width, right? It's
Yeah.
synonymous,
You said
right?
lateral
Geometrically
movement.
speaking,
Yes, but
geometrically speaking, they're synonymous, right?
you said lateral movement. I wasn't talking about lateral movement. I was talking about the lateral width.
Right. And those are the same thing when we're talking about a moving sun. It's where it would appear on the wall left to right, and
Yeah.
none of that is relevant.
Okay, I wasn't talking about the movement. I'll try and rephrase it. You said that the sun compresses vertically, correct?
Many people have provided video proof
Right.
of it,
Yes.
right?
Okay. So then I was just trying to clarify that it doesn't compress horizontally. Is that correct?
Not relevant. If you have any more relevant questions, by all means,
Okay.
ask them.
Okay. Well,
Where are you going with this line of questioning, bro?
my relevant question is if the sun is moving away, would you expect the width of the sun to get smaller during its movement away from us? And have you observed that?
Same way that you see it happen in Dave Weiss's footage.
Was that a yes or a no? I'm not sure.
Your decision. I'm just here to present the data and tell you exactly the conclusions that we're coming to based on the data we have measured in this case in two scenarios, one well before the solstice
Okay.
and one well after.
Sure. Okay. Okay. So have you ever
For geographic
like when
clarity,
I look at the
everybody,
sun compressing,
hold on, Bert. Just for
when
geographic
what?
clarity for everybody, just to be absolutely sure that everybody understands, I'm not in North America. I'm in Uruguay. I'm at 34.5 degrees south, if that has any bearing on what we're looking here at all. I don't
Right.
think it does, but someone might think it's relevant,
Oh,
but I
that's
wouldn't
actually
want to leave
interesting.
out that point.
I don't even know the name of the country you just said. Where are you?
It's on the east coast of South America between Argentina and Brazil, 1.5
Nice.
south.
Bert, are you trying to pivot to an angular size of the sun change argument?
No, that my question was did he observe that? But I'm not trying to pivot to that now.
Is that relevant in his presentation?
It could be, but I mean,
No.
in terms of just the distance to the sun changing.
Right. I don't think that's that has anything to do with what he's presenting, though.
Okay. All right. Well, so but actually, it was. I guess you're right. That was a little bit of a side thought. But I love the compression of the sun as it gets near the horizon. That the vertical compression does happen. Um, and have you had done calculations then of how that would affect um, how that relates to the slowing down? And have you noticed other heavenly bodies or lights slowing down near the horizon also?
What?
Our heavenly body has the brightness value of the sun, so you again would be comparing apples to Winnebagos. What we're talking about here is computing how much of the physical sun in the sky, the apparent sun in the sky, we still see at the moment it
Okay.
fades out. I was
Right.
using the angle 0.995 degrees upward past the peak, 24 and a half meters above that peak, 1,400 meters away, to
Okay.
indicate the upper extremity of the sun as we see it at the moment it fades out. That indicates to you quantitatively, precisely measured and calculated that we are looking at roughly, and frankly, a little bit more than 70% of the sun as it is still not moving down anymore, but just fading out. That is what the data shows.
What does just to clarify? What does the 70% of the sun mean? It means that it's mostly not blocked, or does that mean intensity? What does that mean?
Talking about how much of the sun is above the actual physical sun Earth ecliptic horizon, not counting the 16-meter head start I gave the globies in this
Okay.
analysis.
Yeah,
Okay.
dude, we would see the
Um,
shadow. You would see
Conversely,
it, bro. Like you would see it climb up
right.
the wall if it's going below the curve or the ridge in this case with that
Oh,
16
yeah.
meter. What is it? 16-meter. What is it? A pillar? What is that?
Have you ever have you
It's
ever
the Earth,
seen
it's a
the
ground.
Oh yeah, so it's the
well, I mean
ridge,
that's a good
right?
point. That is a really good point
Yeah,
actually. Have you ever seen
you don't see the shadow make like a hard edge. Like it doesn't go higher than the magnet, which is
have
crazy. I
have you ever
expected it to go towards the magnet a little bit, but it didn't even get close to it. Just
have
faded
you
away.
ever seen have you ever seen the shadow of like the horizon going up the side of Mauna Kea in Hawaii, or like the shadow of a shorter mountain going up the um, the taller mountain
Do that.
behind it on a
Yeah,
sunset or sunrise?
yeah.
So that in that case, the light is actually going in an upward trajectory from the horizon.
Never is, and you're
Hey,
full of
hey,
it.
hey, man of
Wait,
Stone. Man of Stone,
go
are
back.
you the?
You're saying that doesn't happen, Stone? That the
That's what
shadow
I'm
of a
saying.
smaller mountain never goes up, or the
I'm gonna
shadow
tag
of a
you in a
Okay.
video.
horizon
I'll show
never
you a
goes
video,
up?
bro. I'll show you a video with Mount Rainier with the guys on top of the peak of Mount Rainier.
Yeah. Hey,
Sorry, Bart.
But
Man of Stone,
there's
or
videos from there's videos like from people on the beach, like looking at a 20-story high rise, and you can see the shadow
Bert,
of the sunset
shots
going up the
shots from the
building.
beach are not valid. They are entirely a different arena. Shots from the
Okay, but
beach are
there's
entirely
also videos
different.
from the mountains. There's also videos of like a shorter
Okay,
mountain shadow going
what we're what
up a
we're
taller mountain.
what we're witnessing here, ladies and gentlemen, is appeal to possibility. It's a great fallacy,
No,
Bert.
no,
Have you got
they're
anything
definite.
else?
hey,
Well,
man
I'm
of
just
Stone,
saying, but
who's
they're
the
actual
claimant?
videos.
Who's the claimant? The claim
Mm.
of the ball claimer. I just so I know who I'm speaking to.
Oh, that's Bert who's arguing Globy right now.
Okay. Hi, Bert. This is Lowry. I'm
Hey,
actually I'm talking through Nicole's channel because she actually
hey,
logged
Larry.
in. I've never actually been in here before. I've kind of lurked a little bit, but when we do these pie in the sky things about looking at the sky and everything else, I'm sure you guys have gone through this before. I mean, like I'm a gematria guy. You boil shit down to its most basic thing, right? I'm still waiting to see evidence of measurable curvature, evidence of gas pressure next to a vacuum without a container. In 10 years, we haven't been able to find it. And really, water is really that simple. All this pie in the sky stuff, talking about the heavens that we don't understand. We don't understand what it is. We don't know how it works. We know it's a calendar. We know it's a clock. But can you give
But
me
what
an example? Can you give me an example in this particular case where you have found that water in aggregate curves around something? Is
well
there
can we
anybody out there that
Wait,
can
wait,
do that?
wait
wait.
wait
So
wait
hold on. Wait. So the thing
You're
is,
going off topic though here.
yeah,
No,
yeah,
no,
yeah
it's
yeah.
but it is the topic. It is the
No,
topic.
no, wait,
no it's
hold
not the
on, bro.
topic.
So no. So we actually had somebody come in and do a presentation about a specific observation, and so this is the observation that we're focusing on right now, not flat
Okay,
Earth in general, right? So
okay,
we're
all right, I
focusing
got you.
in on
I'll back off.
yeah.
I
So
want to
yeah. So
remind
if you
everybody.
want no. So no, do me a favor. If you want to check out the what we're talking about, there's a link at the top of the page. Click on that, and you'll see exactly what the discussion is.
Yeah, you got it. You
All right.
got it. And just focus on the basics, guys. I'll lurk.
Yeah.
My man.
Cheers.
Okay. And I'll land it with this. So in my PTR Stone, I just put a quick screen grab from my solar watch app. You're familiar with that type of diagram? Yes. This is back to Stone.
Biopic, white lines on a black background, something resemblant of the azimuthal grid of vision showing an elevation angle of something passing across the sky.
Bingo. Right. So that was today's solar arc for where I am at 39 degrees north. I could generate one for 34 degrees south, and it would match what you saw
Okay,
today as to where the sun
so
rose, where it went and came
so
down.
what
So
your the snapshot moment you've got in your bio is, I guess, dawn, because I'm guessing you're in the northern hemisphere. It would be going from left to right for you, and at the right
correct.
extremity, as it meets the horizon, it looks like it's almost going straight down, give or take some angle. You know what I mean? Some obliqueness. That's it's not
Well, yeah,
going
it's not
across
quite straight
anymore
down.
overhead. It's going straight. It's heading straight for the horizon, essentially. You know what I mean? It's not pissing around. It's going straight on down, and
No, it's
there's
not. It's
nothing
not
about
straight down.
your. Oh, it's not straight down. Okay, maybe it's down at an 80-degree angle instead of a 90-degree angle.
No, no,
That's immaterial.
it's about 60 degrees. No, no, it
60
is
degrees down.
material.
No, it's not,
With
because it's a constant rate, is the point. It is a constant rate as it passes ecliptically through the horizon in the Globee model. And we do not see evidence of that in these recordings.
so yeah, I
Hey
mean
Bert, can I
I
ask you something
photographed.
real quick, brother? Because I you guys are going like I mean going in circles here. Could you take
I
a
was trying to end it here.
okay, well before you land the plane, I posted a video for you to kind of get your mind around the concept that we're showing here. So if you look at the YouTube link I posted, right? It shows the famous Mount Rainier shadow being casted upwards toward the clouds, and it shows the sun setting, and it's like, oh, that means globe. Well, if you look at that video, they go right to a perspective of somebody that's a climber, right? A hiker on top of the mountain and seeing that same shadow from the higher than the peak, and you'll notice the shadow never goes higher than the horizon line. That's basically the same exact example that Man of Stone has brought to the table by using his windowsill. It never goes higher than the actual like
Okay.
height of what's actually being occluded. That's the point.
Yeah, no, I mean, there's a lot of videos of people timing the sunset where they're at different elevations, and the person at the higher elevation sees the sunset later as the shadow rises.
Oh,
So, I
have you
mean,
seen the video that I linked? Yeah, yeah. Just have a
I,
good faith
I, I,
conversation, bro. Check it
I,
out.
I, I'll take a look at it when I'm done here. But yeah, I've seen a lot of discussions on this topic, and it always, I mean, passes that there is a shadow that rises. But let me just close out
Hey, Bert,
with
real
stone
quick.
here.
Does the shadow ever rise above the object that's casting it?
Yes,
You got to prove that.
Yeah, can you
yes,
show?
like a shorter mountain can cast a
Yeah,
shadow
sure,
up a
buddy.
higher mountain, for
You
example.
gotta prove
Oh,
that,
you're
and the
talking
one that
about
you're talking about is right there. I just linked it to you. I
I'm
gave
not
it.
sure if I'm not sure if that's the one I'm talking about, because a lot of times they're, yeah. I'll come back to that. Let
the
me
mum.
finish let me finish with stone, and we'll come back to that. Okay.
No, but I think that's what Stone is talking about. That's literally the crux of the discussion, that the
Okay.
shadows
Well,
don't rise higher than the object. So if you're saying that, yo, I have something that contradicts his presentation, I think that would go to the heart of what we're
Present it.
talking about.
Yeah,
Yeah.
show it, man.
all right. Well, again, let me finish what I'm saying, then I'll come back to that. Okay. Deal, beasticles. All right. All right. So the reason I just brought up the solar arc, and this is just from an app on my phone called Solar Watch. You can download it. You can use it to follow the sun every day. Over the past year, I started actually using it on the 2023 annular eclipse when I was in Utah. And I've learned a lot about solar movement from just like, following it. But that yellow arc is, from the center position of someone on the ground, how it follows it. And that is basically a arc of a hoop that is, would, if you mark it off in hours, equal distances around there, as Stone said. It continues from sunrise to sunset. There is that little bit slowing down just before sunrise, or
No, there
after
isn't. That's
sunrise,
the
or
point,
before
Bert.
sunset.
In fact, it's the opposite. Let me break this down for you.
But
In
I've
that
actually
arc,
I've photographed that angle, and that angle
follow
is
me,
actually
Bert.
correct.
Bert, follow me. In terms of angle of elevational change, okay, from the observer in the center of the circle in the flat part, okay, looking up at that arc from overhead to the horizon, there is constant acceleration in the vertical downward component of motion. Would you agree? It's a
Vertical
sinusoidal wave.
downward component. Yes,
Mhm.
it is a sinusoidal wave.
It's
I mean, and if
technically, as it's approaching the horizon, it should be accelerating ever so slightly,
no,
right? It's actually, yes,
no,
as
it's
it goes to with
no,
the,
no,
no, no,
it should be
absolutely.
constant around the hoop. The yellow
As
hoop
it
should be a
approaches
constant
90
speed.
degrees away from zenith, as it approaches 90 degrees away from zenith, it approaches its maximum rate of downward descent towards the horizon, right?
Okay, yeah, I see what you're saying. That is the fastest vertical speed. Yes,
Downward, right?
is just
Now,
before
in the
sunset or after
in the
sunrise.
evidence, in the evidence I present, in the two recordings I present, the opposite happens. It slows down. It's not continuing to
Yeah,
speed up,
literally.
right?
Well, I mean,
It's the
if you take the
exact
whole day,
opposite, Bert.
so if you take the whole day, of course, from high noon it has zero vertical acceleration. As it goes down, it's speeding up, speeding up,
55
speeding up,
minute sample,
and
Bert. Come
and
on.
then and then in the last few minutes, yes, it does slow down. It doesn't slow down that much, but
Isn't.
I would point out one flaw in your measurement of the speed is that you're only looking at this window, and I can see that there are tree branches in the way too, because you can see these other things and such,
Oh
and
no.
the
Well,
ridge
actually,
is
Bert,
not
once again, let me
the
clarify.
ridge is
That's not
also
a
not
tree branch. Those are actually a bug curtain on the outside of the door that is producing a
okay.
translucent effect. There is no obstruction between the peaks,
Okay,
1,400 meters
all right,
away,
I'll
and the
believe you.
door. There's
All right,
nothing but air.
okay. So if the ridge is clear and there's no trees there, then yeah. But my point is because the bottom of the sun hits the ridge and starts disappearing behind the ridge. The top of the sun is continuing to come down. The average height of the illuminated part of the sun that you can see, that becomes that slows down very quickly, because you're cutting off the bottom, cutting off more, cutting off more, cutting off more. And so
Like
the
I covered at
average,
the end.
the centroid of what is left, not obscured by the ridge, is
No,
slowing
Bert.
down.
No, Bert.
It would be
No,
better to put
that's
a
not
solar
correct.
filter on your camera,
No,
and
Bert,
then
that's not
take
correct.
pictures of it and then measure the top of the sun's position,
Yeah,
then you'll see
no,
that it
Bert.
slows down a little bit, but not that
Okay,
much.
2 points, Bert. One, you're talking about the vertical compression of the sun as it approaches the horizon. And in this case, because I'm up so many meters above sea level, that is minimized, right? We're talking about the moment at which it is approaching the horizon. Like I just told you, the
No, being
vertical.
above sea level
Jesus, Bert,
doesn't
I
stop it.
let you speak. Jesus, as the sun
Jesus
is
loves you. I
approaching,
get it. That's
as you get to zenith minus 90 degrees, right? The sun's downward component is constantly increasing its motion, its rate of travel down towards the horizon. In the Globee model, it should be getting faster and faster and faster and reach that peak downward rate of motion just after we see it disappear below the horizon because there are mountains in the way. You know what I mean? It's totally the opposite of what we're describing here in the evidence that we're seeing. The only part of refraction, distortion, compression that is relevant here is affecting the vertical compression, the vertical angular size of the apparent sun we're seeing. And that is what I took the time to specifically measure and precisely measure on the wall and compute using that angle of 0.995 degrees. What we're taking there is a line from the bottom edge of what is on the east wall, the light that passes through 117 millimeters below the center of the red magnet to the bottom edge of the window opening on the door to the sky at the top of the sun. And that is the thing that is defining the bottom edge of what we're seeing on the wall. Okay? It is direct line of sight
I
at
understood
the
all of that.
sun. And we know that it is a direct line of sight because the image on the wall is crispy. It's getting direct sunlight. There's no other ambient daylight coming into
I
this
understand.
because
I
it is
understand that's
so
direct
much
sunlight.
less bright than what we're seeing on the wall.
Okay. Now, do you understand what I meant about as you cut off the bottom of the sun from the ridge, that the centroid, the where the kind of the center of the shadow being projected falling would be, is not going with the top of the sun anymore. It's like stalling,
But
if that makes
the
sense.
bottom edge
And
of the sun should be backlighting that extra 16 meters of ridge, right? The bottom of the sun, the bottom
well, the
third
entire sun
of the
backlights it.
sun should be occluded by the hill. It should be backlighting that ridge and
What do
casting
you
an
what do you mean
upward.
backlighting?
Bert, why aren't you listening? I'm making a point here. The bottom of the sun should be technically, from our viewpoint looking out the window, below that 16-meter line and
Right.
casting an upward shadow through the door and onto the wall. It should be eclipsing. We should see that ridge's shadow, crispy or not, because it's 1,400 meters away, on the wall at some point because the sun is continuing to accelerate
No,
downwards.
no, you don't see
And we
light from the
don't.
bottom of the sun. You don't see light from the bottom of the sun if
Why
it's
don't we
obscured by
see
the
the
ridge.
bottom of the sun?
If
Why
you
don't
if
we
you
see the light from the bottom of the sun?
draw a line from the bottom of the sun to the
Bert,
ridge,
answer
okay,
the
and
question.
then that goes above the window because line of
It
sight
doesn't.
from the bottom of the sun to the
It never
ridge
does,
would miss the
dude.
window.
That's the point of the
Well,
It
okay,
video.
doesn't.
but my all right, but it's not even going. It's not even up. But my point is the ridge is higher than your house, okay, and even if it was much higher than your house, as the sun goes down below it, the light from the bottom of the disk of the sun to the top of the ridge would hit would miss your window. So no, there's no light from that. Like just draw it
You mean
out
it should be above the
geometrically.
window?
From the bottom of the sun is that's why you would have to go up on the roof of your house, someone or
See
on
that
a
edge of the bottom
ladder
of the
to
sun.
see the bottom of the sun when
If
that
that's the
last
case,
picture was
Bert,
taken.
if that's the case, then everything below the bottom edge of my roof below should have shadow from that ridge produced by the sun eclipsing it. And we
Right.
do not
That
see that.
well, first of all, it'd be a blurry shadow. It wouldn't be a crisp shadow like you showed in that
Or not.
first
The point
line.
is, we see none of it.
Yeah, but that doesn't All right. So if I were to model this and use like stray light
Mean like
software and ray tracing.
WJB did? He modeled it. That's what I
I'm,
covered first, right?
okay. So what I'm saying is that if I modeled the globe and the sun coming down, I could include all of this. I wouldn't be. I would get similar
WJB did.
results.
Just like
And
WJB did, which is like what I covered first. The
okay,
expectation that you're setting up. We
I,
should see that, but we don't.
We do not see that, Bert.
what I,
That's the point.
but no, my point is that you modeled it wrong,
Oh, it's
and you're
just
not
wrong. It's
understanding.
just wrong, Stone. The whole time, bro.
No,
Awesome
what?
gaslighting, Bert.
Okay,
Next.
All right,
okay,
it's just
thanks.
wrong.
All right,
Okay, show us how we did it
let
wrong, and then come back with some
Go
actual
go
refutation.
go do
Yeah.
your measurements and come back with your
okay,
presentation instead
so
of these what
again,
ifs nonsense.
the last thing I was just trying to say here. So as the sun
You
moves
said
through
that
this
3 times ago, by
in
the
the
way,
globe
just saying.
in the globe model, yeah, I've been trying to get back to keep on it. In the globe model, and then that the yellow arc represents the sun moving through the sky. Now, we've done this even here on Clubhouse. If you take pictures of the sun throughout the day from sunrise up and back down to sunset, the sun is very active right now with lots of sunspots, and you can see how the sunspots rotate throughout the day.
Who
Now, in the
gives a
globe
shit
model,
about this, Bert?
Relevant
in
at
the globe,
all. Not relevant.
okay, just let me finish, and then I just have a question. Okay, so in the globe model, the sun being far away, its perspective along that arc would just be like if you took a picture of the sun and the sunspots and you followed it along that arc, it would rotate with kind of a certain rotation and come back down. And I'm just wondering, as we've observed that matches the rotation model, I'm putting this out there kind of as a part B,
Hey
to your
Bert,
experiment that you
it
did.
feels like you're
Can
running to your
can
safe place.
hold on,
It
hold
feels like
on, hold on, Linnell.
no,
Hold
Bert,
on, Linnell.
no, no,
I have a
no,
proposition for
Bert,
Finish.
Stone.
Let him
you're
finish
trying
because
to.
I'm going to
Let me
address this. Let him
finish.
finish.
Let me finish, Linnell. It'll take me 30 seconds if I stop getting interrupted. So
Adapt.
I'm asking, hey, Stone, this would be fun to do. Can you replicate the rotation of the sunspots? Can you think of a flat Earth model experiment that we could agree on and we can go out and do to replicate how you would view the sunspots in any given day?
You done with your question? Let me answer it.
Yes.
First off, it is absolutely irrelevant to this analysis. Secondly,
I
if
said this
you
is a
would like
part
to,
B
Bert,
experiment.
for God's sake, let me speak.
Okay, but I didn't say it was
Secondly,
relevant to this experiment.
secondly, if you would like to spend some time arguing about sunspots, by all means, hop on over to my BitChute channel. It's called Man of Stone, real tough to find, and review the three-parter, the three videos that I have put out subsequently, previous to this video, about sunspots. And in those videos, again, you will see empirical data to the effect all you want to know about sunspots, all you want to know about the sun that is not relevant to this conversation.
Okay. I asked a bunch of questions that you didn't want to answer. That's fine.
No, dude, get out of
And
Right,
here,
Bert.
it's
bro.
okay.
Get this guy out of here.
Hey, I'm just saying
Well,
thanks.
to be clear,
Appreciate the conversation.
Gaslight, Bert.
you don't
Sure.
have any answer for the data. You know, the 70% sun above the horizon, the null hypothesis presenting nullifying evidence for the globe hypothesis, while solidifying ours. No answer to any of that, but you did ask questions about sunspots, so that was a good job.
Stone, didn't you find the sunspots going in
No,
all
it's not fun.
directions whenever you analyze the sunspots from Antarctica? That's like
You
not
know,
explainable at all.
yeah, Taylor, that's what I covered a lot in part one of those three parts. I did indeed because McKeegan gave us 22
You
straight
okay, buddy?
hours. Bert, shut the hell up while I'm talking.
Oh,
Taylor,
sorry. I didn't realize I was muted. I was
I think
talking to
he's
my
talking
dog.
to his dog. Yeah, I was gonna
okay,
say I
fine,
knew that. I
fine,
recognize
fine. Keep
that.
on muting. Yeah, in part one of those three, Taylor, yeah, I did spend quite a bit of time analyzing what happens to those sunspot movements relative to their position on the sun over 22 straight hours. And I show about 20 hours of the data because he kind of fudged his camera settings and his ability to track the motion of the sun using the mount that he chose. But yes, there's a fair bit of data on that in part one.
I posted it for you, Stone.
The
And I expect Bert to watch the other video that he said he would watch in good faith, and I would like to hear his
The other
Yeah,
three
I've
videos
grabbed them here.
All right,
What
cool.
what what are the 3 videos? I don't see 3 videos in the chat.
I'll
in
relink it.
succession.
I don't
Maybe
see three
Bert's
videos.
homework,
I see
or
one.
Okay, here's the. I just reposted it for you.
That's the one from before. That's the first
The
one.
third one is called
Yes.
Domi's Homework. The second one
Oh,
is
is
something about,
are they in BitChute? Is that what you're saying? There's
yes,
three
they're on my
videos there.
Bitsuit channel, just like I
Okay.
told you. Check out Man of Stone, and there they are, 3
Hmm.
videos in a row about sunspots.
Fantastic.
Yeah, and then that video that I posted, that's relevant to this conversation. I would recommend watching that if you actually want to come back and discuss this topic. Because that's really the crux of it is, do shadows ever go higher than the height of like,
of
how am
the
I saying?
object, yeah.
Yeah, of the object, right? Like, how tall is that object? Okay, it's casting a shadow. All right, does that shadow ever go higher than the object that's casting the shadow? That's the question. It's been answered with Man of Stone's video twice, and it doesn't do it.
16-meter head start.
And with a 16-meter leeway, like,
But
you
I
know,
would
has
also
nothing to
like
do
to.
with Twilight, has nothing to do with
No, it's
any of
good.
that.
Yeah.
Nothing to do
No,
with
I
the
understand.
size.
Direct sunlight, direct line of sight of the sun. That's good.
so wait, you don't think that it's because of Twilight that all this happens? That's crazy. Would you disagree with
Civil
that?
Twilight. Hold on, let's be civil. Civil Twilight. Yeah, okay.
What do you think, Bert? Does that explain it in any way for you?
Is there anybody else in the audience with comments or questions relevant to the presentation?
Relevant, by the way. Just emphasizing that.
Hero, nothing. Like I know Hero, he's a Glober. I think T's a Glober. T got nothing. I don't want to wait till these guys leave and then you guys have a lot to say. So,
That's how it always happens every time. You know it. We all
all
know.
right, no, that's gonna stay in the ghoul.
All right, I'm going to end the recording that I've been making this evening. I'm going to hand it over to Alan, and he'll be doing a restream on that, I'm sure, with some image
Sure.
augmentation. And thanks for coming, everybody. It's been it's been a blast.
Hey man, this is dope. I appreciate you, man of Stone. It's all right. All
My
right, guys.
absolute pleasure.
Appreciate y'all coming through. Shane, Alan, what's going on, guys? How y'all feel? Appreciate y'all coming, hanging out. We're gonna close this one down so we can save the replay. Liz, you here? I thought I saw Liz pop in. She was sick. All right, that's
Out
what's
there.
up.
Yo,
Jamal,
by the
you had
way,
something you want to say, bro?
yeah, and I was just gonna tell him I was cracking up the other day listening to our boy John say there's something
Yo,
really fishy about the data. It's like, well, when you press it, well, what's so fishy about it? Well, it doesn't match the globe.
yo, Alan, you let him off the hook. You had him. You should have just beaten on him, and you was beating on him for a couple of hours. But once he said that, yo, the thing I find suspicious is that the it doesn't match the globe. You should have just started smacking him upside the head with that shit.
He might be muted right now, but we didn't actually have the data yet. He was looking at it ahead of time and coming to that conclusion, so we were like, huh, okay.
Well, we do have it now, though, so that's super fun.
Yeah. Oh, yeah. I don't want to spoil the surprise.
When y'all gonna do a show on it?
I think we're doing something with
Tuesday.
Jaren on Tuesday. I'm gonna try to show it to Jaren. So.
So just so you guys know, he's still on his. Remember when he started just supposing and conjecturing on the thought process of Heffen when he was doing it. That's where he settled at. Well, I know what he was thinking, and he probably did this, and he probably did that, and then he reverse engineered this.
About
Like,
John?
yeah, yeah,
Oh,
talking about
yeah, yeah.
the theodolite, yeah,
Yeah, then
yeah. You guys going to his? I know he said he invited y'all to his fucking bite of physics. Y'all going?
well, we made the observation for like 14 more stars. So he was like, what happened with this one example was he backwards engineered it and he made it up and he just wanted it to be so it was. That's why he took 14 more measurements. Hilarious. Anyway.
Yeah, the only rebuttal we've heard is it's just a coincidence.
Oh,
Well, stay tuned for stay tuned for Tuesday.
oh shit. Oh, so y'all not going to? He's got a room on here tomorrow. You're not going?
Who, John?
Yeah.
Oh,
He
What's he
said
presenting
invited you
tomorrow?
guys. Yeah, I think it's tomorrow.
What is he
Yeah,
going to
he
present
usually does it on
tomorrow?
Fridays. It's usually a bunch
Yo,
of his
He's going to
colleagues,
talk
his
about the
physicist
celestial
friends.
theodolite. He's going to
Oh,
talk about
really?
it. Yeah, he's literally
we
going to
don't
talk about the shit that he
Oh
was wrong
man, yeah,
about.
y'all gotta pull up, man. That should
we
be
only know how to
interesting
come to
because
this room, guys. We only use Clubhouse for you. We don't know how to do anything else. So
I literally
yeah,
don't know how to
so
change this. If I change anything, I will lose this room. Like I'm on club deck.
that's how I am on Discord. But I guess we'll probably have a room open, so if we can get y'all to follow him, and then we'll go with it. But it's usually a bunch of his colleagues, a bunch of physicists, and a bunch of old stiffs. But they're should make for some interesting sound bites and content.
they're gonna
Hey,
get
just
together and virtue jerk and then congratulate each other for being right without any refutations. That sounds like
Well,
that's
that's
what
what it's going to be interesting to see if you present it in a real formal sort of a way. What do they got? What are they really going to come with?
let them dig themselves a deeper hole. Let us know.
Yeah,
Like they're
yeah. I
not.
mean, we heard John just like in a very very tight radius, biting his tail, just going around in a circle, arguing both positions at the same time.
I made a $200 bet that he's just gonna pretty much just say the same thing he tried to tell you guys, but just to a different audience. And but this audience, they're gonna accept it. They're gonna be like, "Ah, it is a what a coincidence." You know how they usually do. Just one follows the other.
You
So
mean
yeah,
how
he's
he
gonna just.
publicly asks questions that were already answered multiple times, but he's publicly asking them again, like even though they've already been answered?
it doesn't matter that you answered them. It matters that he gets to ask them
PTR.
publicly in his condescending, really super slow diction so that people think he's right.
There you go, nailed it.
Hey, Bert, I'm curious. Did you see? Yeah, you didn't see the presentation, right, of the celestial theodolite? Bert, you there?
He's busy doing gifts.
Hold on. Hey, um, I did see it.
What are
And
your thoughts on that? I'm just
it
curious.
it was just very brief, and so I haven't had time to dig into it. And it seemed to be based on the measurements to mountain peaks, Pikes Peak from um, the guy's house. Is that correct? Are we talking about the same thing?
Well, I mean, we don't need the measurement from the peak to the house, but yeah, it's about angle to the star being occluded by a mountain, calculated by angles for plane trig versus spherical comparison.
Right.
That's what it's about.
Yeah, I mean, we do those calculations all the time for the position of the celestial sphere and stuff, and it always works out for spherical Earth. I haven't had a chance to go through and uh, redo any of his calculations and check them, so I can't comment yet, but I'll get to it.
So what you said was theodolites are mighty comfy right now for you. That's cool. We'll see how long that lasts.
Well, I mean, a theodolite is just a small telescope, hooked up to some nice angular measurement encoders. And if you look at an observatory that has a large telescope, it's basically just a huge theodolite that has much higher angular resolution. And like when you want to point to something, you calculate it based on spherical geometry and the celestial sphere. So, and you always point to the right thing. So it always works. I don't know what you wanted to say about it.
For glob.
Yeah, well,
Yeah,
yeah,
it always
yeah.
works for being on a rotating sphere, where you are on that sphere, what time, and
Well, except it
the
means 14
positions in the
instances, I guess.
celestial
So
sphere. You can
Oh, yeah.
always get your points. So
I guess it works
yeah,
every
so
time
so
except
my
for all
point
these
is the
measurements.
math always works using globular values.
Okay,
So
good, solid.
Therefore, glob. Yeah, sure.
Thanks for your input. Yeah. I don't know
it
anything about
works.
it. I
That's all
haven't
I
read
said.
it, but I'll go ahead and offer you that in my experience, you're always wrong and Earth is blue. So thank you for that.
I
Word of
don't
wisdom.
know how many
Yeah, it's
times
literally
I
what he
have
said.
heard I don't know how many times I have heard Globies use the point, hey man, the math works as a proof for whatever they're talking about at the time.
I wasn't trying to prove anything. I was simply saying that that's the math that they use to point to things, and you point at the right thing. So
Yeah, but
You
that's
see,
it.
you could have just said
that's
I
not
don't know,
scientific.
and I'll
This
look
is
into
funny
it.
that you were lecturing me on how science is done,
I
and
I
that's the
was not making a
opposite.
I was not making a
You see,
hypothesis. I was
what you're
making a
talking about,
statement.
is mathematical reification. It is the opposite of the scientific method. What I
Okay, I
presented
wasn't
here
talking
tonight,
about
Bert,
I wasn't
Bert,
talking
I
in the
let you
context of
speak.
doing science. But
Bert,
you're
I
saying
let you
something I didn't
speak.
say. And you're saying something that I
I
didn't
let you
say.
speak, Bert,
And you're
but you
saying
don't
something
let
that I
me.
didn't say.
You know why you're not letting me speak,
I'm
Bert?
you can
Because you
speak
feel.
all you want, but
Do
you're
you know
saying
why
something I
you're
didn't
not
say
letting me speak, Bert?
because you're lying about what I
Because
said.
no, it's because you feel completely insecure about your position now that you've
Yeah,
been
your
fully
psychological
exposed.
analysis sucks. You must be completely insecure in your position, Stone, to throw
Yeah, I
something at me
rest on
about that like
empirical
that.
evidence. You rest on the math works. Yeah, right.
Okay, the math works, and you just did a presentation saying the math works, and that we can tell the shape of the floor by the
No, I did a
position of lights in the
presentation
sky.
showing the empirical evidence, and then I put math on top of it to prove
Hmm.
certain things about the evidence.
Okay, so did I make a false statement by saying that using globe math, we can know where to point any telescope, and it points to the thing that we
You
expect?
said,
Is that a true statement?
like I
Is
said
that a true
twice,
statement?
therefore glob, and that is what you said. Yeah, and it's not how science is done.
I wasn't making a statement about how science is done, and I asked you a question. Do you agree that the globe math works for doing that? Yes or no?
Actually,
You're
frankly, no,
you're
it
you're accused.
doesn't.
It does because that's what everyone uses, and
All right.
and
All right.
you get where is Sagittarius
Appeal to
A
the
right now?
masses.
No,
Wait, has
no,
Being your
Bert
that
best.
has wait before we go any further, Bert,
logical
have you do you can you
fallacies you can
real
throw it
quick,
out, but
Bert,
it
can you
doesn't
just
work.
show like give a quick steel man of the whole like methodology, or what do you think like how it's devised and what the purpose of it is?
Of what I just said about
The celestial
find.
theodolite.
Well, I mean, if you're talking about measuring the angles of stars relative to a mountain or such, but my point is that you can easily calculate where things should be, and that you can repeat that, and people like do that professionally, whether you're a surveyor, whether you're an astronomer, um, and we just, I mean, just as a matter of
Like
course, it's not even
it's
something
kind
I
of
would argue
deviating from the
about. It's
steel
just
man
something
about
that happens. To steelman
deviating
it, I
from the steel
mean,
man.
Just say you can't steel
yeah.
man it because you haven't looked at it yet. That would be your best position. Just saying.
Well, I said I haven't gone through the calculations to check anything yet. I'm just simply saying, as a matter of course, we can calculate where a star should be all the time using pure globe math, and people literally do that
He's not going to steel
thousands of
man it.
times every day, and it works. That's all I said.
So you understand that it's not actually, quote, globe math, it's celestial sphere math and is based on the azimuthal grid of vision and curved visual space.
I understand how light propagates extremely well. Thank you.
Okay, buddy, that's another issue entirely. Way to sidestep it.
No, that's you said the perspective, field of view, etc., and trying to invoke that it must be just perspective of how things work and such. I've talked to Shane about this
And
before.
such, yeah.
Taking Walter Bislin's model and then just using it as saying, look, it works. When of course we know Walter Bislin's model is based on celestial mechanics of
Oh, the great
orbits.
Walter Bislin, yes.
Oh,
Well,
the celestial
I'm just
mechanics
bringing
that
that up
aren't in the
because
source code
they.
that only exist as a comment in the source code that was removed. Yeah, that's really cool, man. Anyway, what were
Well,
we
no,
saying
actually,
about the true
it's
positions
based on the
of the
ephemeris of
stars being globe
orbits.
math? Have you anyone want to talk about the celestial theodolite?
Tragic.
I'm just kidding. But this is kind of wrapping up, huh?
Peace.
Yeah, it's done.
Nice.
I'd say I roasted him enough, yeah.
Well played. Well played. Well, thanks for having
Yes, and
us,
again,
Flat Earth
I
Gang.
again really want to thank you for pointing out that lights in the sky can verify the shape of the floor.
All right,
Yeah,
bro.
yeah, yeah, yeah.
I can't tell you what the shape
Bruh.
is, but I can tell you what it isn't. Anyway,
So,
Hey, look when John pops in. John pops in
Oh,
into the
John's here, yo,
Ah, there's John posting it. There it is, man.
yo.
so that's
Nice.
the invitation to tomorrow. What time does he say? He said 9:30 a.m.
Nice.
But John's in Cali, so
Yeah,
what's
but
up,
he
man?
knew that this session was happening and when it was happening, and I noticed he did not attend.
He
Yeah.
definitely.
Is John too late for him to pop up? I don't know if he's aware of, if he's seen
Hey,
any.
let's see if we can get a recap. Hold on. Let's see if John wants to throw some refraction on this shit right quick. I
Yeah,
mean,
they're not relevant.
have we had anybody throw refraction on the chat? Coffee or Bert throw refraction on the chat or not? John will definitely throw refraction on it. I got money. Oh, he
Got money
ran.
on the refraction?
Oh, he ran. He fucking ran. Okay.
Peace be upon him. For the
He,
best, really. Because like on the downside of having to talk to John is having to talk to John.
hey man, you know what, Alan?
Shay.
I'm gonna tell you, bro. I was looking at your live and I saw your face when John was resetting in real time. He was NPCing out, and you got a little taste of the shit we've been dealing with for the past couple years. So at that, like, I saw it in your face. It was fucking hilarious. He was
Dude,
NPCing out.
it was so crazy, man. And he did it again the following night. He ended up getting rebanned from Ether Cause because him and Mike and Eric were talking about um, the air in the theodolite, and then you just multiply that by the distance of your observation, and it comes out to this like linear rate that when you convert it over the distances that they're making in their observations, it holds to 8 inches per mile squared, so it's completely equivalent. And John was like, as soon as Mike started bringing it up, John started freaking out and was like, that air is 8 inches per mile square. That's the globe. You're hiding the globe. He started globing out on it, right? So he knew what the numbers meant, right? And then my buddy Eric was like, okay, so all he's doing here is multiplying the air times the distance, and it's giving this relationship. And John was like, oh yeah, I agree. Yeah, it's a completely equivalent. He just linearized it by converting it. And then I was like, okay, so you now agree that it would just be the scaling air would just be the quote unquote globe. And he was like, nope, I don't. That's not what nope. Just started immediately walking it back. So I just had to piece him out.
Oh yeah. No. He's cooked. So sometimes he notices, like he'll catch himself, and then he'll just run. Like his brain will just automatically revert. Right? Too
Yeah.
much real.
Yeah, he'll bail before you get a concession. He'll bail.
Yeah. Or he'll make you ban him by just like repeating the same thing in the
Yeah.
same condescending tone.
Oh yeah, that's his move. That's his special move right there. He'll just keep saying it. He used to get really upset and like he used to spaz out. Like he was bad. Like he had to take a break from the app and go and center himself. And so he came back with that, where he just kind of says the same thing over and over again in a condescending tone. So that's a
Yeah.
new thing that he's
He had to
trying.
get retrained by the CIA or whatever on how to deal with us.
Oh
Yeah, I
yeah.
mean, he met his match with me. Like, argument by argument, you just watched him just weighing down to like one. He just kind of turned into this repeating angular size of the sun, like McToon's silver bullet argument, and it was all he would thump that every day, bang his head on that wall, and still get cooked. But yeah, it was interesting. But you do get really quality sound bites out of him. You get like if you're able to like do his weird dance or whatever and like humor him, you'll get the
Oh,
best, like most quality sound bites out of him.
dude, Pizio crushed him the other night too on EA when he was trying to refract the celestial theodolite. The way it would have come out, the refraction would have been up to like 15 arc minutes, and the mountain would have been I think it would have been like 30 or something. So it wouldn't even be possible, like mathematically, the way he was even asserting it. And he just like he got walked down his own line of logic and then started arguing against it after he proposed it, dude. It's
That's his
like this
MO for
is
sure.
you hate to see it.
Oh yeah. No, he's gonna throw some refraction on it, no matter what you bring out. That's what I'm saying. He's gonna like as soon as he hears this argument, the stone argument, he's going to start refracting it.
Oh,
I
I
guarantee.
don't see how you could refract this one. The outlet I knew he would, right? I told y'all, like, if they'll say candle goo is refracting and fucking silhouetting itself in front of the sun, if it can block the sun, what the fuck is a star? You know what I mean? They'll make it. It'll just reify stellarium.
yeah.
Someone called it ruification in your chat the other day. I was crying.
Well, the
Ruify
problem is now,
the
you know
refraction,
how they say refraction makes everything go down. Well, now they got to refract up to get back over the mountain, and then they got to refract down on the
then
back
back down.
end.
Oh shit!
It's so, dude, they got to do the double reverse refract, bro.
you go.
That's crazy. They'll
That's
do it.
fucking hilarious.
They'll
They
do
And
it.
they
They
will
definitely
do
will.
savages.
it.
They definitely will. Oh no, that's dope. All right, so
But yeah,
sun.
yeah, tune in on Tuesday. I'm gonna be presenting it to Jaron. I'm gonna be going over it with him.
Oh, fire!
Oh my god.
I know.
You know. So what are you guys doing? What's the setup
For what? What do you
for
mean,
you?
like?
So for you and Jaron. So it's gonna be he's coming on your show or what?
Yeah, yeah. So he's heard of the argument, and some people that are against it have talked to him about it, and they're straw manning it. So I messaged him and I was like, "Yo, this argument is really significant, and I'd like to uh, present it to you for for clarification and stuff." And he was like, "Cool, do you want to do it on your show?" And I was like, "Yeah." So we're just gonna set it up. I'm just gonna like lay it out for him and tell him the significance of what's being actually put forward with the measurement.
So what do you like realistically? Now that he's on his new wave, what do you realistically expect him to say when he
Oh,
sees it?
I don't expect him to like flip back or anything like that. He'll probably kind of take the position that the only position that's available right now, and is just to not really acknowledge the significance of it and talk about the observation from Mike's house.
Mm, okay. So he's gonna obfuscate is what you're saying. He's gonna try to skate. Okay.
Yo, what's up with Peace? What's up with Robot Polish? I ain't hear from him in a while. We need some of his because I that first what was it last Thursday? The first room we had with like Heffron came in here. There was a part I wish I'll timestamp, but I'll find the time to go back and get it. Where John he indeed like he conceded that once you get that once you get that angle of the peak, it's
Right.
like you're pretty much there. He said it, and then he just went back on it.
No, he gets it because the thing is, right, if you were to take a theodolite and measure it at that same time, you would measure it pretty close at night to what the globe would predict the value is during the day. Right, but our argument is that that's all optical in the visual field, which is a deviation from the spatial Euclidean field. So, like the spatial field would be where objects actually reside, like in 3D space, and then the visual field is how you perceive it. So, through atmospheric conditions and just optical compression, you're going to see that mountain at 219 degrees, right? Like irrespective of anything. But the significant part is the timing in which you stop seeing the star matches the intersection point of the physically calculated Euclidean position of the mountain and the position and the same with respect to that star. And the only way that could happen geometrically is if the angles was a straight shot to you, which is like that's the biggest part of the implication.
Right.
All
If
right.
he gets it, it's just gonna reify
Yeah. Yeah.
stellarium with the ideal refraction that they need.
I love that the argument that they can make is just to use stellarium how you would normally use it and then present it on a spreadsheet as if it's a new thing. If you do the obs from Mike's house, you're not presenting anything new that stellarium wouldn't tell you. Like that's not using the celestial theodolite to confirm the globe. That's literally just stellarium.
Just stellarium, confirm it's stellarium.
Yeah. It's like, yeah, that's the key distinction. Yeah, it'll be cool to present that and get the argument actually out there, and more people will see it, and hopefully more people try to take some measurements of it.
All right. That's dope. So you guys gonna do it on Tuesday? So is that all you're gonna talk about? Is the theodolite?
Yeah. Oh, yes. Just the theodolite specifically, and actually on Monday too, we're doing an update on Earth Awakening server to the celestial theodolite. So if you want to catch that one too, because Mike just dropped a PDF that has all of his measurements and timings and everything. So we went through last night and confirmed everything, and we got everything confirmed. So we're gonna. The big contention last week was that this is just a coincidence and it has to be repeated, yada yada. Um,
Right.
and they were denying the measurements, the additional ones, right? But we didn't have like all the data available and confirmed it yet, so we couldn't really argue on it. But now that we have it all, I mean, it's like, what are you going to argue now? That it's a coincidence that happens everywhere?
All right. He's gonna argue that you reverse engineered it. Watch.
Yeah.
Remember when he did that? He put on his Matlock hat when Shane first came in with the 2.16 millimeter aperture Riley's
Yeah, yeah, yeah.
criteria
Yeah,
reverse engineering report.
yeah, yeah.
Oh, right, right.
Yeah. So he's going to claim error, um, manipulated data, and he just doesn't believe it. And
I
then
hope
he's going to
so.
go and do it. He's going to go and do it his way. Because remember, he was trying to. He's like, yeah, he's going to do it his way. He's got his own way that he wants to do it. He's going
Oh
to
my
come
god.
back with his way and claim that his way is right, and he got different data, and his matches the globe. This is my prediction. You heard it here. It's on fucking audio. It's recorded. Watch what I
And then
say.
when Stone popped up last week and just mentioned curved visual space, he just not it right away. Like he was like, "I'll just leave that there. It's just not. It's not true. Like it's not a thing. I guess."
Yeah. Yeah, once they start acknowledging that stuff, it's over because they don't account for anything other than globe curvature and refraction. So if they start admitting to optical effects, like there's not going to be any room for Earth curve. So they have to say not only is the spatial field Euclidean, which we agree, but they have to also say that the visual field is Euclidean, which strong disagree.
All right. It's gonna be lit.
Yep.
All right, Alan. We're gonna close this joint now. We're gonna open up after dark.
All
This
right,
is
my
good, brother.
man.
Hey man, I appreciate y'all
Or
coming
appreciate
through though.
y'all.
This is dope. All right. Hey guys, I'm gonna close this down. We'll open up flat earth after dark. All right.
Yep.
All right, doing
Later, lads and ladettes.
See you
Peace.
later, Alan.
See y'all in a minute.
All right, everyone. Thanks for tuning in to Mana Stone's special guest presentation on Clubhouse with the hashtag Flat Earth Gang. If you're not on Clubhouse app, when you have an iPhone and or Android, you should definitely hit up the app, hit and join there. Those guys are awesome. And then tomorrow will be the Twitter community space. So tune into that at 8 p.m. sharp. We will be going live in the front lines of Twitter. And then Sunday will be Glowbusters, where Zachary Zimbala, Good Times for All, is going to be presenting on electrostatics. And we're going to be getting into the old downward vector a little bit there. And then Monday and Tuesday will be celestial theodolighting. One on Earth Awakenings with the boys. The other one will be with the ex-flat earther formerly known as Jaren. So tune into that. See you guys next week or tomorrow and next